Hi, I'm Konrad. I am what a friend of mine once described as a seasoned data scientist, which always conjures an image of, I don't know, exotic spices being involved. What it means in practice is that I've been crunching numbers for a living for so long that I remember when the joke, who's a data scientist, a statistician with a MacBook, was still funny, which is north of 15 years by now. I've done all sorts of things, finance, high-frequency trading. It's probably faster to enumerate what I haven't dabbled in terms of doing bad things with data. Luckily, there's no such thing as a Geneva Convention for data that gives us some leeway on that front. And today, I'm going to talk to you about personalization. And before I get to the actual presentation, Juliana, I think, no, sorry, you don't need to switch. I can do it myself. Okay, do you guys see the content of the presentation?
Yeah.
Loading. It's loading.
We actually can already see it.
Okay, good. That's a step in the right direction.
Konrad, before you start, how do you want to do the part of the questions? Do you want to respond at the end of your presentation, or just?
No, by all means, ask in the meantime. If I happen not to react because I don't know, I have a flow or something, then someone just please interrupt me in the chat. I think that will be fastest.
All right, whatever you feel suits you
No,
better.
That's absolutely fine by me.
Okay.
So, without further ado, it took some thinking about the title. So I settled with, this time it's personal reinforcement learning for mere mortals, because everywhere you look, you hear something about reinforcement learning, people talking about reinforcement learning, this and that, but how many people actually use it? Well, this is a more or less summary of my attempt to do something about it. Why should we bother? By the way, this presentation is mostly geared towards the topic of e-commerce because, well, it's a big business in general, and these days in particular, it's double so probably since yesterday, the announcements. So there's a bunch of reasons why that's the topic of my presentation. So why? Personalization for users and obviously making more money in these somewhat challenging times. There's a lot of data floating around, and whatever we do needs to work at scale. And how? Without spoiling myself, an explanation of the shortcuts is coming soon. So why do we bother? E-commerce in the Netherlands alone, before Corona, and it's probably safe to say that during Corona we should add like another, I don't know, 30–40% by initial estimates. That's a 25 billion euro business in 2019 alone. Worldwide, the numbers involved are of a kind that you normally see in, I don't know, particle physics books or central bank balance sheets, because we're talking trillions. The thing is, everybody wants a slice of that cake. However, well, the cake is finite. No matter how many smart devices people have at home, within the Netherlands, for instance, there is a limit how many people can be drawn into your network and how many of them are actually going to click on stuff. Like, unless someone has a serious, I don't know, addiction problem on that front, they won't be clicking all day long and buying compulsively, which means a bunch of companies who want a piece of that cake or entities, whatever, are competing for a finite set of resources. Finite pool of potential users or buyers. So the question is, how do you differentiate from yourself from that bunch? It's a terrible thing that I have to share it in that manner because I don't know how to do it within Hangout because I had a fancy stuff with scrolling and bullet points appearing. Never mind, let's go. What do we want to do for our users? We want to give them what they need. Meaning, if you go to, I don't know, Marktplatz, Zalando, Waycamp, you name it, and you're looking for a pair of cargo pants, nobody's going to show you bicycles or ballet dancing shoes, which means it's necessary to personalize it towards what you need. We need to do it quickly, because in this day and age, everybody is used to, well, having pretty much instantaneous reaction. I mean, psychologists talk a lot about instant gratification syndrome and whatnot. And the third thing, we need to be flexible, because the world changes. What was popular yesterday, and, well, fashion changes is the simplest example, doesn't necessarily have to be the case, excuse me, tomorrow. So we need to adjust for that. How do we go about it? Well, as is frequently the case, we can use things that people came up with in math. In this instance, a topic of reinforcement learning. I most sincerely apologize if to some of you I am repeating stuff that is already known, but that's, I'm afraid, the peril of preparing a presentation for a potentially diverse audience. So, apologies a priori. I'll try not to repeat myself too much. If, on the other hand, the topic is less familiar to some of you, then, as I said earlier, just ask along the way. And if I don't notice it in the chat, someone please draw my attention to it. So, the point about reinforcement learning, how is it different from other ways of approaching topics in machine learning? Well, number one, it's about making decisions sequentially. Things happen. In the context, for instance, of an e-commerce website, users just keep coming. They want to click on stuff, they want to buy stuff, they want to view stuff that interests them, which means we don't really have the luxury that we would typically have with supervised learning, where we have a static data set, we know what's going on, we train there, we evaluate it in our validation, apply it on test, yada, yada. That's not the case here. We need to keep updating what's going on because, things happen sequentially. We need to react to the environment, meaning environment can be generally a pretty broad concept. It can refer to, well, the variables describing the situation in which we are operating, but it can be also, due to the flexibility of reinforcement learning as a framework, this can be, I don't know, the setup of your game. The beauty of reinforcement learning as an approach, it doesn't really matter that much. We gather the information about the environment, then we take some sort of action. That's the basic principle here. We get information about what's going on around us, we take an action, and then we get some form of feedback, meaning we did a good job or we did a lousy job. So, say in the context of a game, then, well, we made a move that ended up with a massive loss. If it's in the context sticking to personalization of business, well, we made a decision that made the user go away. He charmed. He didn't like us. Our stuff took too long, or we showed the person something that wasn't really that relevant to them. The field, this is by no means intended as even an introduction to reinforcement learning, because people spend entire careers working on that topic alone. So what I will do here is I will touch it. I mean, the very concept of Markovian decision processes, like I know professors who write about nothing but subclasses of that one. So this is more or less reinforcement learning. What happens in terms of reinforcement learning in practice? This is Exhibit A, tic-tac-toe. Pretty much everyone who has been, well, for primary school, because you probably get bored by high school, has spent a break being bored and playing tic-tac-toe. It's a very useful thing to present an, what would you call it, introductory approach. This is the principle how you structure a game. You can analyze it from a game theoretic point of view. You can write your fun agent to model the game of tic-tac-toe. What it isn't, is it isn't particularly useful in practice. In terms of, well, unless you want to win a championship in tic-tac-toe, if such a thing exists. There's also Exhibit B, things like Starcraft, which I'm fairly certain, given the size of the audience, at least some of you are familiar with. For those who are not, real-time strategy game, fast-paced action, a lot of moving parts. If you ever want to see people operating in superhuman speed and processing data, look up something like Korean Starcraft Championship, because in Korea, Starcraft is practically a national sport. Those people make decisions and click mouse faster than I can type. So that's actually quite impressive. Point being, this is something that was Google's claim to fame. Look, our reinforcement learning agent, and I see something in the chat. I see. Okay, good. That's nice. It's impressive. It's useful. Well, for Google to show their chops. Not so much when it comes to doing actually something in business. This is more or less the situation of reinforcement learning. You either have toy examples or really fancy stuff that's fun to watch for 10 minutes, and then you ask yourself, what's the actual point here? I made the second point more specific because I managed to locate the source of the original statement that big data is like teenage sex. Everybody talks about it. Everybody thinks everyone else is doing it, but no one really knows what's going on. That's more or less the situation with big data in general and reinforcement learning applied to it in particular. Because things like supervised learning, classification, yeah, for all intents and purposes, that has gone mainstream, especially ever since people started what I personally consider a borderline abomination, the AutoML type of frameworks, where you don't have to understand what you're doing, you don't have to code, you don't have to do anything. Essentially, it's like an Excel for machine learning. And if anybody thinks 2008 was a problem because people without understanding of math were using pretty advanced math to price derivative instruments, wait to see what happens when people who have no idea about math start using artificial intelligence, as easy as they could have used Excel. Because I personally think this is going to make 2008 look like a warm-up. That being said, the question is, what can we do about it? Because venting is fun, but it's not very practical. This is pretty much your garden variety website. I mean, addresses differ, language differs, etc. But the one thing that happens in a lot of places is that you're gonna see ads, unless you have a really decent ad blocker or something. Those ads aren't there just because the owners of the website are doing it from the goodness of their hearts. They are there because, well, they sell the real estate, allowing people to advertise their stuff. The question is, how do we know when, for instance, I go to weather.com, how do they decide? They want to show me swim tees, which I assume is a variation of a swimming suit. And yeah, okay, that one was not a roaring success, given me as a target audience. So maybe they should work a bit on the recommendation algorithm. Point is, the principle holds. When you as a user come to the website, even if you are not registered, because if you are registered, the web shop, for instance, probably has some sort of information about you. There's I think something like 10% chance someone did the number that you actually bothered to fill out your data, your gender, your name, your age bracket, those kinds of things. Even if not, you probably have some purchase history, so people know what to recommend to you. On that basis, a decision can be made what kind of ads you want to show. And even if that is not the case, well, you are coming at a certain time. You are coming from a certain type of device. You are using maybe a browser, maybe an app. All of this is information that can be used to achieve some form of personalization. So, what do we want to do if we want to really start personalizing and satisfying all the conditions I indicated earlier? So we want to make it fast, we want to show people what they need, and we want to react to a changing environment. Essentially, it comes down to what would you call it? Balancing two conflicting, slightly objectives that are slightly at odds with one another. On the one hand, we want to explore what we already know. If we know that someone is coming in the evening and browsing from an Android, yeah, we can make a semi-educated guess that it might be a man. And this is actually a funny thing. Even under GDPR regime, where obviously we all have to be super careful with personal data. Operating system of your mobile device is a decent predictor. Android is much more popular among men. Like, I have no idea why, but it has been empirically confirmed from a couple of places. So you do know a thing or two. On the other hand, the world changes. Maybe tomorrow, iPhone releases the absolutely most masculine looking iPhone in history. And then that proportion won't be, that predictor won't work anymore, which means the world will have changed by then. And we have to start thinking how to do something about it, which means we need to exploit the environment. Sorry, I flipped exploration and exploitation. We need to exploit what we know, but we also need to explore the unknown. So we are not permanently stuck. We maybe want to inspire the users. That's a rather big word in this context. And then what do we do? Well, essentially, we followed the lead of Mr. John Langford, guy who used to originally be at Yahoo. Him and his research group were probably the most valuable thing about Yahoo. Like that and some stock that I think the Chinese later bought. And someone at Microsoft had a very brilliant idea to raid Yahoo, poach Langford and his team, and he's now at Microsoft. He came up with the idea, let's take the principles of reinforcement learning, so balancing exploration of exploitation, reacting to the environment, etc., and strip it down to a bare minimum, something that will actually work in practice without, either falling into the, oh, let's make a cute example about how we do tic-tac-toe, trap on one end, and on the other, excuse me, not Corona, I'm just not that used to talking lately. On the other, well, do something that's actually useful. Because as I mentioned, Starcraft is fun, it doesn't make you money. Well, unless you want to promote a new graphics card. So he formulated the framework called Contextual Multiarmed Bandits. Again, apologies for those who are familiar with the topic already. The basic idea behind multi-armed bandits is, as is the case with a lot of algorithms, inspired by real life. If you ever been in a casino, seen a movie where the plot takes place in a casino or something, then you probably know what a one-armed bandit is. Essentially, rolling wheels in front of you, and you're supposed to pull the lever at the right moment to align them in a given configuration, and then yada yada, the plot of the movie continues. Multi-armed bandit, as far as I understand, not that I have a lot of experience with casinos, is an extension of the same concept, except you can pull two levers. Well, being a mathematician, Langford was like, well, let's extend it to an arbitrary number and cast it in this framework. And that's more or less what he did when he formulated the concept. The idea goes like this. For a regular multi-armed bandit, you select one of possible actions, sticking to that example, which lever to pull, and you get a reward. Meaning, well, either you hit the jackpot, and there's a flash of coins falling out of your machine. By the way, in Corona times, probably going to be a problem because cash is apparently evil, or you didn't, which means the environment you operated in gave you a feedback. For a contextual bandit, we extend this by making the action dependent on the state of the environment, which means we don't merely interact with the environment by saying, I did something and then this happened, but before I take an action, I also take a look around. Like, there's this ugly looking guy standing behind me. Maybe this is not the optimal moment for me to come up with a lot of cash. So we need to take the action into account, the environment into account. And contextual bandit, the middle block of this one, is the framework that we will be talking about, we'll continue talking about today. Full-blown reinforcement learning problem. There's a reason contextual bandits are like a gateway drug into reinforcement learning. You also look at the previous state, which means you don't just look at what happened now, you take into account what happened in the environment before. Like, okay, the ugly guy is not standing here now, but he was there 5 minutes ago. So maybe just went to do what he had to do. He's about to come back. And also, what did I do before? What actions have I taken previously? Because, well, I won 3 times in a row. Maybe I should think a bit whether I'm not falling, what's it called, the gambler fallacy, where people start thinking that if a certain sequence of events occurred, they are more likely to repeat afterwards, which is bonkers. But don't tell that to casino owners because they'll be heartbroken, especially to their clients. So Contextual Bandit is the setup that we are operating in right now. Where was I? How does it work in practice? It's a repeated sequence of action. We observe the context. What's the environment at the moment? We choose the action we'll deliver of a given type, and then we observe what happened. It can be called, well, we can call observe the loss, observe the cost, observe the reward. For this action, and this chosen action, this is an important bit here, because we do not see what would have happened otherwise. And this is a very important difference compared to, for instance, supervised learning, where you can, well, you can backtest, you can test out of sample. In this instance, you do not have that. So what you do, you only know what happened. There is a whole branch of research around so-called counterfactual examination, which means you try to theorize what if, and then, yeah, hope for the best that this is a decent approximation of reality. But for all intents and purposes, we only know what happened with the actions that we chose, not what would have happened otherwise. An important, well, not limitation, condition in order to make the algebra workable in practice is that we have a finite, not that big set of possible actions. You can generalize it into something that's not discrete but continuous, because if you look at, I don't know, autonomous driving, for instance, this is a pure proper reinforcement learning problem, and there, I don't know, messing with the steering wheel. This is something that happens continuously. You can turn a little bit, and then a little bit more, and then a little bit more. It's not like you can enumerate that with a steering wheel in a car, you only have 4 possible positions. So that's also a baked-in assumption or requirement in this instance. We have a bunch of possible strategies to balance exploration and exploitation. That's a big thing, and that's the first real movement into reinforcement learning, the biggest change that contextual bandits are making compared to your garden variety supervised learning algorithm. Finally, because we are updating and learning along the way, that means the parameters of our model, whatever they turn out to be, they are changing over time. On the one hand, that introduces a slight risk because things might be a little less stable, obviously. On the other, it makes you much, what would you call it, better protected against concept drift. And concept drift is a fancy technical term for saying the assumptions I made when I built the model on my training sample don't hold anymore. Which means the distribution of my output is not really that close to my input. If you're doing this in a pure supervised learning environment, you can kind of bootstrap your way out of this one by doing adversarial learning, because you're just trying to find out which samples in your test set are most similar to the ones in the training set and focus on those. But if this is a live environment where new observations just keep on coming, then yeah, you have to try and control for it in some way along the way. I really wanted to insert this picture for a while because that's a terrifying rabbit. For those of you who have seen Monty Python and the Holy Grail, probably remember the killer bunny from Antioquia. That's more or less the original source of inspiration for this one, because when Mr. Langford was coming up with an idea for his algorithm, he was I think he must have been very tired, because in his own words, he named the algorithm Vorpal, which is what this thing was called. And then he thought, how would Elmer Fudd, this, this huntsman guy from Looney Tunes, how would he pronounce it? And that's how Vorpal came to be. Spoken from experience, if you've been sitting on a scientific type of problem for too long and it's 2 a.m. and the coffee is not working anymore, you tend to consider things funny, which you would not consider funny at 10 a.m. So from experience, I can understand that. Be that as it may, Vorpal Wabbit is, for all intents and purposes, the Kalashnikov rifle of machine learning algorithms. It's like if you talk to any weapons buff, there's one weapon that's indestructible. Like you can throw it from a plane, you can ride over it with a tank, throw it underwater, it will still work. That's more or less the case with Vorpal Wabbit. It doesn't need a GPU, it doesn't need fancy, I don't know, really powerful CPU because, well, it's working in an online manner, meaning it processes an example at a time. So from experience, I once fed it, I think, a 60 gigabyte text file, like 7 or 8 years ago, on a 4 gigabyte RAM machine. And it worked. It worked. It produced the result it was supposed to be. It was supposed to. Which, by the way, the minimal memory footprint might start becoming relevant, I think, because on the one hand, you have things like the GPT-3, oh my goodness, artificial intelligence has arrived. And then some, say, evil, cynical people close to my heart started asking, what's the CO2 footprint? And it turns out it's enough to power a bunch of households, I think, for a month. Like the cost was, I think, 3 million just in the CPU, the GPU time burned, carbon footprint, yeah, that kind of thing. There is a possibility people might actually start asking those kinds of questions, in which case, well, whoever uses Vorpal at the time can be like, funny that you mention it. So that will come in handy. What does Vorpal do? The basic philosophy behind Vorpal, it's kind of like there's this, for lack of a better term, philosophical paradigm. You can do things the Windows way or the Linux way. The Windows way is you have one tool that does everything. It doesn't do any of those things particularly well, but it does all of them. Textbook example of that, if any of you have ever had the displeasure of working with SAS. That's more or less what SAS is. It tries to be a database, it tries to be a statistical computing engine, tries to be a reporting engine, a bunch of other things in between. Polar opposite of that, needless to say, of which I'm a huge fan, is what I would call the Linux philosophy. For each problem, you have one tool that does this thing and this thing only, but it does it really, really well. And then you stitch a bunch of them together. That's more or less what Vorpal is doing. The core algorithm behind Vorpal is you have a linear regression model, or logistic regression, for that, not that it matters this much in this context, which is really fast, really efficient, working in an online manner, yada, yada. And then the more advanced stuff you want to do, you essentially slap on top of that linear learner, which means you can have a neural network, well, single layer perception, let's not overplay it. You can have an SVM, and you can have, for instance, a contextual multi-armed bandit. And all of those things are running on the same engine that's applied in fairly sophisticated manner. Like, I wouldn't call myself a C programmer by any definition of the term, but I can read C. I read that code, and I was like, okay, wow. Like, seriously, wow, those people are good. And last but not least, in our current cost-conscious era, fully open source. You just grab it, install it. For those of us who are allergic to doing things from the command line, which is the baseline mode of using Vorpal, it also has a Python binding. So you can fire it from inside the notebook, if that is your heart's desire. One thing that, well, everything comes at a price. This is what an input format to Vorpal looks like. What you have is, you have an ID of your example, so essentially a row ID, what do you call it? You have the label, and you have a concept of namespaces. Namespace in the context of Vorpal is that usually what happens in practice, you have most like tabular type data sets. You have some numerical features and you have some categorical ones. Usually treating everything as numbers is not such a good idea because, well, you can encode, for instance, a gender as man, woman, 1 and 2, That means your model is implicitly making comparisons, saying gender 1 is bigger than gender 2, which is idiotic and potentially insulting to people. So that's another good reason not to do it. In Vorpal, you don't care. You just encode the features as categorical, and that's it. Effectively, what happens under the hood is that it gets written down as a set of dummies, and if the cardinality is too big, what they apply is called a hashing trick, which means effectively doing everything modulo a pretty large number. The advantage of that, slightly technical, so tangent, but it's useful because it puts a limit to specify the parameter, the size of your hashing table, which translates to how big is the number where you do the modular operations. Then you put a ceiling on how much memory is your algorithm likely to confuse, which means the chance of, well, Vorpal blowing up on you because you ate all the memory available, which anybody who has ever used Chrome knows as an experience. Well, that just doesn't happen. So that helps. From command line, because, well, being 42, I'm partial to command line. And yeah, if you feel like throwing a Douglas Adams hitchhiker guy joke, knock yourself out. I've been hearing them for entire last year. What you do once you have formatted your training data set into this format, for my convenience, although that's not strictly necessary, what I do is I just append it with an extension VV, is say VV, Vorpal, train on this data set, output the model here. There's like I think 5 pages worth of command line options which you can append to do all the more fancy stuff. Regularize your model, how many bytes to use in your hashing table, etc. Thing is, if you really go to town with it, your call to your model starts looking like a black magic invocation in your console, but it works. It works, and it only hurts at the beginning. After a while, you get used to it. Testing, equally simple. Throw out your predictions. This is it. Why am I mentioning this part? Because this is, as far as I'm concerned, major advantage of Vorpal. Whatever your data is, you can pretty much shell script all of it, fire it, have it run periodically, and not, come back the next morning, see what the results are. How does Vorpal implement a contextual multi-armed bandit? First thing, it allows for a bunch of different exploration strategies, because if you want to explore what could have happened, what are the possibilities, well, you can do it in a bunch of ways. You can, for instance, always, I don't know, at each point in time, say with probability, I don't know, 90% probability, I keep updating based on this new example, based on, with 10% probability, I am taking an action at random just to see what happens. Or you can have a more structured rule around that. Or you can, I believe that's what bugging does, like explore first. What it does, in simple terms, it does random stuff, shows that it just picks actions at random for a while to find out what happens. On that basis, establishes what are the rewards associated with different actions, and then proceeds learning. Epsilon greedy keeps alternating. With probability epsilon, which is usually a small one, hopefully, we take a random action. With 1 minus epsilon, we just keep learning and continuing the exploitation based on what we know. Bugging does a sort of hybrid of the two, batches over time. What's the brilliance of this one? I always like this old joke that describes the problem of a mathematician who's given a piece of wood with 2 nails in it. One is hammered all the way in, the other is hammered halfway there. And yeah, apologies for those who already heard this one. So what does a mathematician do? He starts with the one hammered all the way in, because that's the more interesting case. Once he has solved this one, he moves to the one hammered halfway in. What's the first thing he does? He hammers it all the way in to reduce it to a known case. This is literally what we are doing here, because we have worked out, royal we, succession of people over the centuries, you know, standing on the shoulders of giants and all that, how to handle classification problems, which means this is a pretty well understood domain. So the exploitation part can effectively be reformulated as a cost-sensitive classification in a multi-class variant with classes corresponding to the actions that our algorithm takes. Another important bit in practice, because in general, those problems are structured as, well, we exploit a bit and then we explore, but that implicitly says we have a live environment where we can experiment and say, okay, observations keep coming, I don't know, from 1 p.m. to 3:30, I'm just gonna be taking random actions as people come along, and then I'm actually gonna start utilizing that knowledge. But this is not always practical. Like, if this is a business where customers keep coming all day long, chances of, well, okay, maybe people will be fine with doing an A/B on a small subset, but nobody's going to allow you just to experiment on a live production setup. Which means, on the other hand, there's a solid chance, at least if the company is keeping their nose clean in terms of their data management, that they have a lot of recorded data, like old historical data. There's information there. We can exploit it. There are also all sorts of hybrid combinations between those situations, and this is what we can leverage. We can go for pure exploitation, which in practical terms means saying, okay, my historical data set is so big, it's been so diverse over time, I don't need to explore anymore. I can just assume I've picked up all the knowledge I had to pick up, now I just need to leverage it. You can say, well, I want to explore a bit, but I know what are the possible actions that I'm willing to take, and I know it, and this is not going to change. And that's the case of the number of actions being known a priori. Or that might not necessarily be the case. Maybe I am optimizing for an advertising campaign, and in that campaign, well, I have a bunch of possible ads I can show, and it will be running for a month, but after the first week, I know I will get new ones to use. What does it translate to in modeling terms? That means the set of possible actions is not fixed a priori. That might change over time, and it will depend on the context, in this instance on time. So we want to be able to do something in that situation as well. And that's where the explore ADF. ADF stands for action-dependent features. Means. If you recall the picture of weather.com that we have seen in the beginning, this is more or less the use case for this one. What do you want to do? Well, the same thing most establishments want to do. You want people to, like, I don't know, wake up, Zalando, Marktplaats, you name it. You want the buyers to be able to buy cheaply. You want sellers to be able to sell as expensively as they can get away with. And since you are not operating a charity, you want to be able to make money in the process. So how much can we charge people for promoting their stuff on our page and still get away with it? Which is pretty much what establishing equilibrium between supply and demand comes down to. And everybody wants to make money. Select which ads you show where. In practice, what this problem is often rephrased as, it's not like you can place an ad everywhere. Like, this is limited because there's their toolbar. There's a bit here. There's a bit here. Maybe on another website, there would be another one here. That's, I believe, what people refer to as the real estate on the web page. And the question is, in this setup, what do we show where? Like, maybe it works better if we show clothing at the upper panel, whereas, I don't know, food supplements on the right-hand side, or maybe the other way around. And this is what we are trying to decide here. Example data might look something like this. The actual values are not super realistic, but the general format, that's more or less what it is. Well, after cleaning up, because in practice, 9 cases out of 10, this would be lying in a monstrosity of a JSON somewhere, which you first need to clean up. We know where we are. Sorry, we know when we are. We know what time is it. We know the group of ads from which we want to pull stuff. We have the descriptions, typically in a problem like this. We know something more about the ads, so inventory type might be the topic the ad is referring to, broader category, or maybe a division, a split, is it a static one or something with an animation, those kinds of things. The size, obviously. This is historical data we're talking about, so we already know prior impressions and what device, what type of device did someone enter our website from. Was it a mobile device of some sort, on a browser, on a certain operating system, etc., etc. Relevant bit, action proportion. This is assuming that we are only exploiting the data, which means we looked back and said, okay, as I mentioned earlier, my data set is long enough, diverse enough, I know all there is, so I can calculate what's the probability of choosing this action for a given context. That's what the empirical probability, what the action proportion stands for. And then we have the reward, which is how much will the advertisers pay us once this ad is clicked or viewed, depending, because both situations are possible. After formatting to Vorpal, this is what our data set might look like. We have the action that was taken. We have the negative reward, because, well, in all fairness, for mathematical convenience, whether you always want to optimize some sort of objective function, which means you're trying to find a minimum or you try to find a maximum. From a mathematical standpoint, it doesn't really matter if you are maximizing something or minimizing something. You just need to flip a sign sometimes, which is literally what the creators of Vorpal did. They assumed it would be easier to implement minimizing the regret, which means instead of looking at reward, we look at the loss, namely minus the reward, because convention. And then we have so this is the reward or loss, and then we have the empirical probability of the action. As you can see, nothing particularly fancy. If your data set is particularly humongous, you can safely skip the features that are 0, because then Vorpal, if it has a missing value, the algorithm will implicitly assume that if a feature is absent, that means that its value is 0 for a given instance. Where was I? Yes. So, casting the problem of trying to show the best ads to the best people at the given time on their best devices, etc. How do we cast this problem in the reinforcement learning framework? What's our decision? Which ad pool do we use? Do we use the, well, whatever our division is, animated or static, category, etc. And where do we place it? The categorical features. What do we know? Who's the user? If we know something about the user, I mean, for the purpose of this setup, it doesn't really matter if we know something about the user, like is identified, has history, blah, blah, or we just leverage the information that is available to us legally anyway. So type of device, browser, etc. Something that we know about the user that is relevant for the context here. Time, attributes, etc. What are the actions? Well, what do we place where? Reward, that's also a relevant bit. Reward can happen instantly. Namely, we know someone clicked or something or they didn't, or it can happen after a while. Because maybe our objective is trying to, I don't know, minimize churn, increase people's involvement with the website, and then we want to know after a while whether they stayed there or they actually left and never to come back. So for the purpose of this one, I'm assuming we know the reward right away, but that does not a priori have to be the case. Yes. And we will be comparing two models. Namely, we will be comparing a linear model. So our predictor, which decides, sorry, I turned the camera off because I need to plug in charger, and I don't want to overburden you with stimuli along the way. Where was I? Yes. So we'll be comparing two models. One linear, so just your garden variety multinomial regression, and quadratic, meaning within this setup, we are looking not just at the categorical features, but also at all the possible interactions. And this is what happens. The blue line is what really happened historically, as in ads that were manually selected to be used by the analyst. Clearly, judging by the looks of it, wasn't that great. Orange is what happens when we apply a linear model. So as you can see, there is a similar pattern that all of them follow to a degree. There's a peak here, trough here, etc. This is because the reward, the way you calculate it in this context, is well, the value of your click times the number of clicks. So that's why there is a sort of similar underlying component in all of them. We just multiply them by different things corresponding to the ads that were chosen or ad pools that were chosen per point in time. And quadratic model seems to be working remarkably well in this context, which clearly shows that taking into account the interaction, so not just it happened at 4 p.m. or it happened just on the iPhone, but no, we differentiate between someone who came at 4 p.m. from an iPhone versus at 4 p.m. from Android, or 6 p.m. from an iPhone, meaning, well, yeah, we take interactions into account. Not an awful lot of point in me repeating it 7 different ways. This is what the revenue looks like over time. And, well, translates also to cumulative, because this was at each point and then cumulative. Obviously, if you are trying to solve a problem like this, and this is the cumulative revenue that you can show over time, especially if this is your baseline, yeah, you are in a good place business-wise. This is a second example based on where we split our historical data set between training and validation. Difference between quadratic and the baseline becomes even more pronounced. Although even in this context, you can see, yeah, for parts of it, the linear is doing better. The quadratic is not, which means there is usually quite a bit to investigate in terms of details on this one. Yeah, and coming to a close, because I have 4 minutes. That's good timing. Okay, so we've built a linear model, built a model in Vorpal that learns in an online fashion. What happens next? Well, first of all, the first thing you need to do in a context like this is to do a proper A/B test, because counterfactual examination like the ones we did, assuming that historical data represents everything, etc., this is to a degree Baron Münchhausen kind of approach. We are improvising, pulling ourselves by our own bootstraps because we do not have any other option, really. However, until you try it live, you won't really know how good it was. So setting up a proper A/B is an important thing. Messing around a bit more with exploration, because for the sake of this example, I just assumed that we go for pure exploitation. Yeah. Incorporate the problem of delayed reward. As I said, this simplifies the consideration for the sake of this conversation in terms of, well, I observe it instantaneously, but that doesn't necessarily have to be the case. And this is something also to keep in mind. If you consider moving beyond Vorpal or doing something more ambitious, then Pandora's box labeled deep learning is waiting for you, because I did say for a reason that Vorpal and the linear plus extensions model, that's a bit of a gateway drug here, but you can obviously use much more fancy stuff. Simplest way to think about it, more sophisticated models usually give better predictions. Not always, but frequently. There's a solid chance if you have a complicated space in terms of your context, using a deep learning instead of linear model of interactions might help. However, Vorpal doesn't quite work that far. Finally, because the universe is not limited to this one, you can explore those kinds of ideas. By the way, to the best of my knowledge, Contextual Bandit is implemented in all of them. First, because I think that's the most recent among those, is TF agents. I mean, Google seems to be on a mission. All your algorithms belong to us, and they want people to they want TensorFlow to be a one-stop shop. It started out as a deep learning framework, but a while ago they also implemented boosted trees, which, other than a marketing ploy, I don't understand, because the performance is grossly inferior to things like XGBoost or LGBM. But it does have the advantage of convenience. I'll give them that. They also implemented a reinforcement learning framework. That's what they call the TF agents. I mean, it's a fishy status because officially it's not part of TensorFlow. It's kind of affiliated. You have AutoML. Important distinction: TF agents and dopamine, which is more pros, are using for research. Those are open source. AutoML is not. However, if you're not that concerned about the budget for GCP credits, then you're good to go with this one. Yeah, that's it.
All right, Konrad, thank you so much. I think it would be nice to have your camera on again. Perfect. Nice. So I think we could have maybe a bit like a couple of minutes to have some questions from the crowd. Maybe if you guys want to just unmute the microphone and just go for it, please do so. If you feel more comfortable writing the question on the chat, that's also fine for us, I assume.
And if you do not, then yeah, well, Juliana has my contact details. So should something come to you as an idea in a while, you know where to find me.
Yeah.
I have a question. So since you are working in e-commerce, so this is the big problem, right? So e-commerce have kind of a techie DevOps team, but not completely. So doing kind of a full hardcore DQN reinforcement learning is of course very difficult, because you need to have a very good streaming infrastructure. You also then on top of it need to be able to have proper inference. But now that you want to do reinforcement learning, there is kind of the exploration and the feedback kind of service that you have to deploy on top of it. So, but in a more realistic setting, how would you, for example, try to harness insights from a B test, or what would be kind of the first, let's say, reinforcement learning projects you would try and deploy at an e-commerce company, like any kind of brick and mortar company that is now trying to digitize itself and has kind of a digital shop?
Bandit, hands down, because especially if you can get away with skipping exploration, then you can effectively reformulate it, which is what I alluded to here, as a linear model. Linear model with reductions on top, interactions, blah, blah, blah. But the important part is, if you formulate as a linear model, maybe with some, I don't know, logistic function or something on top, then this is something you can effectively encode in SQL. Which means if you can, I'm not an engineer, but I understand enough about, for instance, I don't know, Elasticsearch, to know that if I can formulate something as a SQL statement, and it's good enough to be parked in an Elastic query, and it will work fast, which means it can run and give recommendations real time practically. Because
does this require very expensive infrastructure? Because if you have like the traffic similar to eBay, and you have the bandits, then you want to kind of update the the weights, even if it's a linear model, you want to update it real time, right? So
yes and no. In an ideal case, yes, but if you mess around a little bit, like I know I mentioned a lot the topic, the issue of non-stationarity and the universe changing, but that might be partly because I'm a cynic and pessimist. So I am assuming bad things will happen in data, the structure will change, etc. And my model might stop working, so I need to worry about that. But sometimes that worry is excessive, because models, it's not like everything changes from hour to hour in traffic patterns. So you can, without much problem, get away with things like update the model daily. I mean, this doesn't take a long time to train. So even if you schedule it as something like, I don't know, every day at 1 a.m., you park stuff in your cron tab, get me the latest data, update the model, upload it there. Yes, it's not perfect in terms of model parameters to calibration. Yes, thank you, Eric. Sorry, talking coherently and typing at the same time is a little bit above me today. Thank you for being here. Where was I? Yeah, it's not perfect. It's not proper kosher reinforcement learning. However, what it achieves is it gets you a foot in the door, because a topic that's not mentioned in a lot of, that doesn't get a lot of mention in this context, is that a lot of people talk about AI. But when it comes to like, yeah, guys, in order to actually do AI, as you said, you need infrastructure. Oh crap, that means actual work to do for engineers or something. Yeah, you know, we'll try to prioritize you somewhere at the end of next quarter. Whereas if you start with something that you know as a data scientist is somewhat simplified, you can already show that it works, buys you some goodwill. Next time this conversation you'll be having about this topic will go easier.
Great, thank you.
You compromise a little bit on the rigor in order to get it done. Does that answer your question?
Yes, thank you very much. Thank you.
Of course.
Right, do we have any other question?
That doesn't seem to be the case. Thank you, Anik. Ollie just rushed to the camera, which I only see because he's in the upper right corner.
If Ollie has a question.
I don't know, he's still on mute. Oh, come on, don't sell yourself short, man. My mom's a lecturer and she always told me anybody can explain a hard topic with difficult vocabulary.
I have another question if nobody has one. So Multiarmed Bandit, or the talk that you presented so far, is very dependent on getting your rewards as immediately as possible. So this is something classical that you will have at the B2C kind of e-commerce. But if you have kind of a B2B time e-commerce where the response, the reward will come maybe a week later, this can, for example, happen for email marketing, for example.
Yes.
Yes. So how would you kind of adapt this, or maybe are there kind of other type of approaches you can use for reinforcement learning?
Yes, there are. What I presented here is essentially, God, I hate the jargon, but it's appropriate here, an MVP for a bandit on real life data. There's two ways, what would you call it, to solve this problem. One is super crude, namely, if you can at least somewhat attribute, like, because there's two things. There's delay and there's attribution. One is a delay. If I'm observing the reward for this user, but not instantly with a delay, it's not a huge deal. It's not a huge deal. I'm just shifting my reward by time to match it on the same time axis. Boom, that's it. If there's issue of attribution, that's a slightly different conversation, because then it's like, yeah, I know that bunch of people clicked, but I only got a revenue based on, I don't know, a bunch of customers to whom I've shown it. There are ways. They are what people frequently say beyond the scope of the current presentation, but it's not like the contextual bandit won't work without it. It will. It will. The math becomes a bit more messy and the algebra behind it, but it is doable. You can incorporate it and explicitly model it as a feature of your situation.
Yeah, thank you. Thank you.
Sure.
Right, maybe we leave it for a last question.
Well, it's 20 to 7 for all of us, so.
Yeah, I think for the number.
I may have one more question.
I'm all ears.
So in this presentation, you mostly focused on contextual bandits.
Yes.
When would you move on to a full MDP? what are the pitfalls, or when at what point would you consider the contextual bandit not sufficient anymore, and you would maybe move on to the full reinforcement learning process and consider Markov decision processes?
Probably if I continued running offline testing, and I reached two conclusions. One, if I run a proper or more advanced model offline, and it gives me substantial improvement over Bandit in an offline setting, I'm like, okay, there might be something to it. Ditto for the deep learning approaches. But the second thing, and that's super important in this context as well, and that is, do I have an infrastructure to support it? Because as I mentioned earlier, Contextual Bandit will pretty much run as a SQL query. It's going to involve some torment and abuse of the syntax, but you can make it work. You can't pull it off with a deep learning model or more sophisticated stuff where you have to implement like a Markov decision proper Markov decision process directly. Yeah, those two things. I would need to be convinced that it actually really works so much better offline that I am confident it's not just a data artifact, there is something to it. And I know that there is infrastructure to support it, because if it's affirmative on the first one and nope on the other, then I will save myself the pain and frustration of having those conversations and continue trying to milk what I have that's working.
Okay. And is there a way to extend contextual bandits to multiple actions, where I maybe take 3 or 4 actions that result in a reward?
Pretty certain, yeah. Like I'm not sure what's the official party line approach to it, but from the top of my head, I would just say you treat the combinations of the actions you are taking as a sort of meta action. And say you have levels of 1 to 10, and you can, I don't know, pick any combination of 3. Well, you have 10 over 3 possible actions, and then you treat those as your meta actions. It won't be a full-blown 10 over 3 because some never occur or are extremely unlikely or lead to exactly the same outcomes, yada, yada. But yeah, that's pretty much what you would do. Sorry, that's what I would do. That's something you can do.
Yeah, thanks.
Is there any good use case? Is a recommendation of personalization? Is there any good use case for reinforcement learning? Well, autonomous driving. Pretty much anything related to autonomous driving. Well, like, guys, you're Xomnia. Xomnia shipping. Hello, you know this stuff better than I do. But beyond like actual engineering, if we are operating in the more abstract, let's be honest, e-commerce is an abstraction at a certain level. Personalization, well, everything related to recommendation. I have seen it applied. There was this paper a couple of years ago. It was the Great Contextual Bandit Bake-Off, where they pitted a bunch of algorithms like this against each other. There were a few data sets that are benchmarks. It's like, Iris data set for classification and MNIST for computer vision. Although I think ImageNet's kind of moving to that one. Never mind. There was something about particle physics. We were supposed to predict stuff, but I only studied physics for a year. So I'm not gonna pretend to have an intelligent opinion here. In terms of business applications, the ones I am most aware of is stuff related to e-commerce, so recommendation, personalization, essentially clickability, and things like supply chain. So essentially a somewhat brute force-ish approach to messing with graphs. But I am out on a limb here because this is stuff I just read and haven't studied in anything resembling the detail. My pleasure.
All right, Konrad, I think it has been really interesting. I have to admit, I'm not super technical, so I couldn't follow all the details about it.
There's a reason I treated formulas like a radioactive dump. I think, like Stephen Hawking, I think, said once that every time he uses a formula, he loses half the audience. And I'm like, if that's an approach that was good enough for Stephen Hawking, it's certainly good enough for me.
Maybe later we can just get you and I more in deep discussion about this, and you guys.
Juliana, as soon as the lockdown is lifted.
Perfect, nice. Well, Konrad, I wish you a good day, a good night. Thank you so much for your
time. Very much.
It's been really nice to have you in our segment.
It's a pleasure to be. Thanks for having me.